Hey folks, so it's that time of the year again, and here we are with Advent of Code day one. So I was about to solve these problems, and last year I did like a whole Medium blog thing. This time I thought I'll just record some videos with some pointers to help you understand how to think about some of the problems that are here. I hope you find it helpful, and let's get started. Hi, this is mid edit Jatin here. So, I wanted to request you folks to not blindly copy and paste these puzzles and problems in ChatGPT or Claude or any other LLM and try to solve this problem like a puzzle with a pen and paper first. Most of the times, when even working on real life problems, writing code is usually the last step. So, with that out of the way, let's take a look at the problems. So I'm using an Draw whiteboard here to basically take some notes here. Uh, I hope that would be also easy to understand. My handwriting is not the best, but I'll try my best. So how this works is like if you see on the left, we have the day one open. And Advent of Code, I think it unlocks one problem every day. So you can see here, I think on the day two in 3 hours and 15 minutes, we will have the second problem, and then till 25th December, the Christmas, we will see like total of 25 problems. So let's get started with the first one. And usually all the problems are Christmas theme, and you can use anything to solve any language. Some people, I have even seen them using Scala, JavaScript, I don't know, brain fuck, like whatever you want. We will be most likely using Python to solve it. But I'm not interested in just writing the code. My interest in making this video is to help you understand how to solve the problem. And then I'm going to leave out the part where you can write code. So treat this as basically just a simple explanation of the problem. How this works is like, since there are 25 problems, each day you can make 2 stars, total of 50 stars, 25 into 2. And basically every day you have two puzzles that are there. So let's deep dive into the problem. So it starts here. It says that you haven't even left yet, and the group of elvish senior historians have already hit a problem. So it seems like their list of locations to check is currently empty. So, like in very simple terms, it gives us like that there is some kind of a location list that is empty. This is an empty array, and they decide that the best place to check would be the chief historian's office. So they look into the office, and then they confirm that chief historian is nowhere to be found, and they find like a lot of notes and list which has some significant locations. And this was the planning that chief historian was doing before he left, and perhaps they can be used to determine which locations to search. So looking at this, like I think they found like significant locations are listed, but not by name and but by a unique number called location ID. So it seems like we have a bunch of location IDs that are uh, like noted down by like some number, maybe an integer. And what they do is they decide to split into two groups to search the office, and then they create their own complete list of location IDs. And there is a problem that when they hold these two lists side by side, these lists are not very similar because, like, if since they made two groups, it seems like they came up with a bunch of their two lists. So we can see an example here that we have like a list A and we have a list B. And in the list A, we have 3, 4, 2, 1, 3, 3. And in the list 2, we can see we have 4, 3, 5, 3, 9, 3. And we can clearly see like very quick analysis that we have a 9 here, but we don't have a 9, but we have a 1 here, and we don't have a 1. So clearly there is no link between them. So maybe the lists are only off by a small amount, maybe. To find out, we have to pair up the numbers and measure how far apart they are. So the problem states that pair up the smallest number in the left list with the smallest number in the right list, and then the second smallest number in the left number, and the second smallest right number, and so on. So what we are being asked to do is, like if you look at here, the smallest number is 1, and smallest number in this list seems to be 3. So we will take the first occurrence of 3, and then we will pair this. And if you see the second number it seems like we will have to go with 2. It seems like we will have 3, and we will pair this and so on. And what we have to do is, it says that with each pair, so like we have a pair of 1, 3, 2, 3, and so on, figure out how far apart these two numbers are, and you will need to add up all of those distances. For example, if you pair a 3 from a left list of 7, blah, blah, blah. Yeah, so it's basically trying to run through the same example. So let's do a dry run, and I think I can denote it. So let's continue. So 1, 3, 2, 3. The next largest number I see is 3. The next largest number, smallest number, sorry, is 3. So we will pair 3. Let's choose another color. We have another one, 3 here. But after 3, we have 4 here. And then if we keep going, let's take a pink color. We have another 3 here, but now we have 5. And if we take some other color, maybe like a teal color, we have 4, and then we have 9. So if I write down these pairs, we have something like, let's write them here. So we have 1, comma 3. The second one was 2, comma 3. Then we have 3, comma 3 here. Then we have 3, comma 4. And then we have another 3, comma 5. And then we have the last number 4, comma 9. So these are the pairs that we get. And what it's saying is like we have to find the difference between them, and then we have to do a sum of them. So if we do like a difference between them here, we get like 2, 1, 0, 1, 2, and 5. And if I do like a sum of these numbers, we get 2 plus 1, 3 plus 1, 4, 4 and 5, 9 plus 2, 11. And which is exactly what we got in this example. So now your actual left and right list may contain many location IDs, and what is the total distance between each of the list? So it seems like we are able to very easily do it manually. Now I leave it up to you to think on how we will do it with the code. And I can give you a hint, right? Like if we look at the puzzle input here, the puzzle input is huge. Like we have a lot, it's lots and lots and lots of numbers. And if I were to copy them and move them in my VS Code, I can see we have around 1,000 numbers that are there. So now you have to think of an efficient way of basically picking the smallest number. So I think one of the key things here is to understand that how you can get like the smallest number from each list. Like you have to get their difference. So difference as in B minus A. And then C is you have to basically do like a sum of all B, like whatever you get from B. So now I will stop recording and I will go back on writing the code. This is where I'm going to give you a hint if you want. So the hint is fairly simple, that instead of finding the smallest number every time, your life becomes much simpler, that if you take both of these lists and you sort them, and then you basically just take the numbers together. So instead of storing this in a different pair, you can dynamically just do like B minus A and do a sum of them. So all the best, and do share your GitHub repositories, and I will write the code. So if you want to see the code, I have created a new repository here. So you can find this link, bookmark it, and do share like your code examples. Well, welcome back. So as we discussed, like this approach worked for me, and I was able to add an answer, and I was able to move to part 2. So let's see the part 2, and I'm going to blur this. But the first puzzle is complete. I got 1 star. So let's see what's the part 2. So I will make some space. Let's move a little down, and maybe I'll just add here part 2. So let's see. So it says that your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Yeah, because we got like a large number. So this is like 1, 2, 3, 4, 5, 6, 7 digit number. The historians cannot agree on which group made mistakes or how to read most of the chief's handwriting. Like sounds like me. But in the commotion, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers are not the location IDs at all, but rather misinterpreted handwriting. At this time, you will need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times the number appear in the right list. So they have completely changed. Like I think what we did initially. So it's basically probably going to be the same input, but like we want to try something else now. And we have an example with the sample. So again, let's look at it. So we have a list. Yeah, so we have a list A and we have a list B. So in list A, we have 3, 4, 2, 1, 3, 3. And in the list B, we have 4, 3, 5, 3, 9, 3. And what they are saying is now that we have to first take one number. So let's take green color. We take the first number, which is 3. And then we have to count how many times it appears in the right list. So it appears exactly 1, 2, and 3 times. And so the similarity score increases by 3 cross 3, 9. So we will multiply this by 3. The answer comes like 9. So similarly, now let's pick 4. We see 4 comes 1 time. So we multiply this with 1. This becomes 4. Now we pick 2. I don't see 2 anywhere, so I'm hoping we will multiply by 0. So let's confirm here. Yeah, so in the example, it shows that it will become 0. Coming to 1, don't see it. 0, 0. Coming back to 3, that will, okay, so repetition is allowed. So we will multiply by 3 and then multiply this by 3, which gets us a score of 9 and 9. Doing a sum of all, we see 9 into 3, 27 plus 4, 31. Like this. Is that the correct? Yeah. So I think now we have to do the same thing and calculate the similarity score. So again, I'm not going to show you the code. I'm just going to write it and push it to my GitHub repository. But if you were to do it, a very simple hint would be now, remember how I told you in the last one that we can basically sort the list to make it simpler. Here, think of what kind of pre-processing we can do here so that it's very easy for me to find. Of course, there is one way where I can pick one and then I can do like a linear progression and try to count how many of them are. And since there are only like 1,000 entries, that will most likely work. But think in terms of like how we can make this more efficient. And spoiler alert, you may want to look into like a dictionary or a hash map based on what language you are using, so that it's very quick for you, like possibly a O of 1 runtime to find the number of occurrence of each number in the other list and then calculate this part. Hope it was helpful and I will go ahead and write some code. All the best. So yeah, using the approach we shared, we were able to solve the second part as well. So if I move back, I have 2 stars, and now in 2 hours and 40 minutes, we will have another problem. So I will create a similar video on the same thing. And yeah, if you have a feedback where I can explain it a little better, do share. I will try to write this a little bit more cleanly. Maybe I will find like a better tool. But yeah, do comment and let me know if you found this helpful. All the best.